Hello students, welcome back. We are going to start our main class on the R and the SPSS stream. So basically, as I said in the first video, we'll be starting with R. So once we are done with the R, then we jump to the SPSS. So this will be our first video on R, right? So we are starting with arithmetics in R. So you see, in our junior high schools, we did a lot of basic calculation, addition, subtraction, multiplication, finding the power of something, doing board mass, etc., modular arithmetic, etc. Right? So R can be used as what a calculator to do all this kind of stuff that we did in our junior high schools. So we are starting with R, using R for arithmetic. So for arithmetic, we know we have addition, subtraction, multiplication, and division, as you can see down here. So for here, for addition, if we have this, as you can see on my screen, 10 plus 5 plus 50 plus 34, right? It's addition, normal addition. So once you code this nicely in R and then you execute, it's surely going to come, right? So here, you just put your cursor here. As you are written these codes nicely, just put your cursor here and then run, right? You just run. Once you run, you see R has given us the addition of 10 plus 5 plus 50 plus 34. As you can see here is what? 99. Right? So when you come to subtraction, it's the same thing. So once we have 10 minus 5, the answer is going to give us 5. So once you run, R is going to give us what? 10 minus what? 5. 10 minus 5. You are surely going to get your 5. So we just you just type as you see on the screen, right? You can type and then follow, and you see everything that we are doing will appear on your laptop too. And then if you have multiplication, so R can also use to multiply numbers. So we have 12 times 45, right? So in our normal mathematical class, we see the multiplication sign doesn't look like this one, right? But in R, we use the star to represent what? Multiplication. So 12 times 45. So 12 star 45 will give us what? R will give us the answer for that. So once you put the cursor there and run, see, you are getting 540, right? And then R2 can also use to divide our numbers, right? So as you can see at the top there, we have 34 divided by 78. So 34 divided by 78 is surely going to give us what? Our answer. Once you run, you can see down here 0.43589, right? And then when you come to the exponential too, right? When we come to the, especially if we are working with indices, we have, let's say, 10 raised to the power 3, 90 raised to the power 2. We just write the 10 and then raised to the power at the top of the number, and then just write the 3 there. That expansion will give us 10 times 10 times 10. But if you want to write a power, a number raised to a power in R, you don't just do that, just writing the number at the top. No, you use this bend down sign, as you can see on the screen here. You use this bend down sign, right, to represent what? An exponent in R. So at the end of the day, once you execute this one, this is surely going to give us 1000, and R is going to give us the answer, right? You see this one is what? 1000, and then 90 raised to the power 2 is what? 90 raised to the power 2 is also going to give us what? An answer, right? As you can see down here. So at the end of the day, you see that R can be used for what? Arithmetic, right? And then in our junior high schools, we did what we call board mass and then pen dots, right? So as you can see here, these operations are execution in reverse order of what? Appearance, due to the order of what? Operation. So you may have an expression that have different form of what? Arithmetic signs inside. So which one should we tackle first, right? We have what we call board mass, but basically here we are going to concentrate on the pen mass, right? Pen dots, right? So the pen dots here, the P stand for what? The parenthesis. The E stand for what? Exponential. The M stand for what? Multiplication. The D stand for what? Division. The A stand for what? Addition. And the S stand for what? Subtraction, as you can see here. So once we have an expression that has different form of signs inside, right? We are going to solve it using what? The order of what? The pen dots, right? We are going to solve using the order of what? The pen dots. So the order of pen dots here will help us to what? Just solve the mathematical question nicely without making any mistake. So at the end of the day, we have this one. So once you put the cursor here, you see you have 2 plus 3 times 5 raised to the power 2. So which 1 is coming first, right? So once you put it in R, I will give you the answer. Nice answer. As you can see here, this one has given an answer of 77. And then we have this one too, bracket open 2 plus 3 times what, 5 raised to the power 2. So once you put the cursor here and then run, R2 is going to give us what? A nice answer. So R can also be used to solve what? Bodmer's or Pendar's what? Equations, right? And then let's come to what? Modulo arithmetics, right? Right now we have learned arithmetics, and we have also been introduced to what? The Pendar's, right? So you can use R for doing your arithmetic equation. You can also use R to do arithmetic equation. So for modulo arithmetics that we have in R, for modular arithmetic that we have in our junior high school that we solve manually. So here in R, we can also use what? We can also use what? Modulo arithmetic in what? R. So at the end of the day, you see, we use the double percentage sign. As you can see now, we use the double percentage sign to represent what? Modulo, right? So if you want to find, let's say, 100 mod 75, you just write 100 and the percentage sign will come at the middle of the 100 and the 75, and then run it, and you are surely going to get your answer, right? So 100 modulo what? 75. Once you run 100 modulo 75, you are going to get what? 25, right? Yes. And then you see, also in our junior high school, we came across what we call natural log, right? Exponent, right? We came across square roots and what? Absolute, right? And then so for R, so as you can see here, so as you can see here, so as I was saying, we use this log, right, function to represent what? Natural log in what? R. Then we use the S, as you can see here, S function to raise a number, right? So raise e to a power of its what? Argument, right? So this is e, an exponential function, right? Just raise it to a certain power, right? So as you can see here, is the e raised to the power 10, right? And then we have the square, that's the sqrt, right? Here function is used to, let's say, square root of what? A certain what? Argument, right? And then we have the absolute here to return the absolute value of what? Its what? Argument, right? So at the end of the day, if you want to find a natural log of, let's say, 3.7857, so 3.7857, as you can see here, right? 3.7857, as you can. So if you want to find the natural log of that, right, you just write the log in R and then put that number inside, right? So once you execute it, your result will come nicely down here, right? That's natural log of 3.7857, right? And then we have the exponential function. So let's say if we have e raised to the power a certain number, right? This is how you write it. So that's the SEP bracket open. Let's say e raised to the power a certain number like 10, as you can see on my screen. So 10, once you run the 10, right, once you run it, you are going to get this result, right? And if you have e raised to the power negative 12, and then you want to run it, once you run it, you are surely going to get this result, as you will be seeing on the screen. So maybe you want to find a square root of a number, right? You use this function to find a square root of what? A number. So as you can see down there, if you want to find square root of 49, R2 can do that one for you. So once you run it, it will come. Square root of 49 is what? 7, right? Let's say if you want to find square root of 81, square root of 81 too is what? 9. R will surely give us our answer, as you can see down there, right? So at the end of the day, you see, R can be used to do almost all the mathematical calculations that we use our hands to do manually. If you know how to code it, it will be very simple for you. If you want to find an absolute of a number, you know that absolute of a negative number is what? Positive, and absolute of a positive number two is what? Positive. So here, if you want to find the absolute of a certain number, use the ABS. Right? For instance, if you want to find absolute of what? Negative 10. So absolute of negative 10 is surely going to give us what? 10. Right? So once you run, you see your 10. Absolute value of negative 20 is surely going to give us 20, because absolute number of absolute of a negative number is surely going to give you the positive number, right? So at the end of the day, that is how we can work with what? The log, the exponential function, the square root, and then the absolute what value we want R. And then at the end of the day, you see we have pi. That we use mathematics a lot. So if you want to code pi in R, you just use what you call the pi, right? This pi represents what pi in R, and you know that pi also represents 3.142 usually in 3 decimal place. So R has given us in this number, right? And then secondly, maybe you would like to, let's say, run a certain number, right? So let's say we have okay, we use the run function to run numbers to what the nearest whole number, right? So for instance, if you want to, let's say, run this one to the nearest whole number 233, right, 0.234. If you want to run this one to the nearest whole number, you just put the cursor there and then just click on run. So once you run it, you are going to get 233, as you can see here. But for example, if you want to run it to a particular decimal place, right, you just type the run argument, put in your what, you just type the run function, put in your argument, and what, the digit is equal to 5, you know, the digit here is equal to a certain number, is going to run it to that particular number. So here the digit is equal to 5, we are going to run it to what, 5 decimal place. So if in case here was changed to let's say 3, right, you are just going to run it to what, 3 decimal place. So when you come here, you see, I'm going to run this one to 3 decimal place. So I will do that 1 2 for you. Once you click here, you see I've written run it to 3 decimal place. When you come here, you have 0.234. So that 0.234 is here. That's written run it to what, 3 decimal place, right? So that is how R also works when you want to run numbers to the nearest whole number or nearest decimal place. So for this one too, we have what you call floor and then ceiling, right? So the floor function is used to run what, a number down, right? Even if, let's say, you want to run it to let's say 1 decimal place, if you want to run it to, let's say, a whole number, and there is a number at the down, and there is a number here that when you run it, it can add to the 2, for the 2 to the 3. No, it will still remain 2, as you can see here, right? So you just want to run the number down toward a whole number, and when you come to the ceiling, you just run numbers up, right? You just run the numbers up. So here, you see, when you run this one, you are supposed to still, if you want to run it to a whole number, you are still supposed to get what, 2. But here, the answer is going to give us 3, as you can see here. So I don't know, let's run this one and see, right? So once you click on run, he has given us 2. That's for the floor. The floor is going to give us number down. Are you going to write the number down? And then this one is going to write, the ceiling is going to run numbers up, right? So as you can see here, this is 2.01. This one, there was no case that this number was supposed to be 3 here, but R will run it up to the nearest whole number, right? To the nearest integer, right? So if you have 2.01, the nearest integer is what? 3. So R is going to run it to 3, right? So this one is going to run it down the floor. It's going to run it down. So as you can see there, so that is how the floor and the ceiling too also works, right? And then you also have what you call the trunk function, but that one too you will be introduced to, right, in our subsequent videos, how we work on that. So basically, this is arithmetic in what R. So please kindly take your time and then go through all the codes that you have seen me writing. You can also take your time, write it and run it. You really appreciate it and love it, right? Thank you for joining the class. Thank you for registering. Kindly watch it. After watching, share it to your friends, like and subscribe so that other people too will get interest of it. Thank you and see you another time.